Part A asks how many cubic feet of snow have accumulated on the driveway by 6 a.m. So we know that the question is asking for an amount because it says how many cubic feet. So in order to find the amount, we have to take the integral from 0 to 6 because it's asking for how much snow has accumulated by 6 a.m. So we take the integral of f of t from 0 to 6. And as you know, f of t is 7t e to the cosine t. So once you put that in your calculator, you get the answer of 142.275 cubic feet. Part B asks us to find the rate of change of the volume of snow on the driveway by 8 a.m. So rate of change is another way of saying what is the rate. So because we know that both f of t and g of t are rates, we will be able to find that time. Now, how do we do this? Because it's asking for at 8 a.m., we will plug in 8 for f of t and 8 for g of t. Now, based on the piecewise function, we can see that 8 occurs at 108 because it is in the interval of 7 is greater than or equal to t, or 7 is less than or equal to t, or 7 is less than or equal to 9. So basically we just plug in 8 for f of t, and then you just put in 108 because that's the time at 8. You do the calculations in your calculator, and you will get an answer of negative 59.582. Don't forget to box your answer. Although part C may seem hard, it is only asking for us to basically part C is asking for us to create a new piecewise function with the domain 0 is greater than or equal to t, which is greater than or equal to 9. So they give us rates, and now how do you find an amount? So in order to find an amount when given a rate, you have to take the integral. So basically we have to take the integral of every of g of t based on the piecewise function they gave us before. So we would take the we would do h of 0, which is h of 0 plus the integral from 0 dt. Then you would do h of 6 plus the integral from 6 to 7 of 125 t minus 6 dt. Now you have to change the bounds in order to satisfy the equation. Now you would do the same steps for the integral from 7 to 9, but however this time you will have to add 125 and plus 108 and then do t minus 7. Basically, where I'm getting the t minus 7 from and the t minus 6 from h of 6 before is that you have to subtract the time minus the a in the interval. So in this case, in the bound from the bounds, in this case the bounds was 7 and the bounds for the other equation was 6. Now once you have the bounds, you basically just take what you found and put it into a new piecewise function that is now going to be called h of t. So while I write that down, and that will be your final answer, and you will also use this answer in part C to help you find the answer in part D. So this is very crucial and valuable that you know how to. For part D is asking how many cubic feet of snow are on the driveway at 9 a.m. So in order to do this, they're asking for an amount. So we have to take the integral, which is something you need to know how to do for this problem. So basically, they're asking from the bounds for this are 0 to 9. So they're asking 0 to 6, 6 to 7, and 9 to 7. So as you can see, I did 125, 7 minus 6, and then minus 108, 9 minus 7, which is 26.334 cubic feet.
So for part A, you need to approximate the rate at time t equals 6. So you see, you have to do 21 minus 13 over 7 minus 5, which in turn gets you 8 over 2. So once you get 8 over 2, you get 4 because 8 divided by 2 is 4. So since the question wants you to put in 100 to do 400 entries, and that's your answer. You just box that answer up. But there's one important thing that you cannot forget. Do not forget this. You need to do the slope formula, which is y2 minus y1 over x2 minus x1. Don't forget that. So for AP Calculus 2010, B reads, use a trapezoidal sum with the four subintervals given by the table to approximate the value of 1/8 the interval from 0 to 8 e of t dt. Using correct units, explain the meaning of 1/2 from 0 to integral from 0 to 8 et dt in terms of the number of entries. So for the first, you have to use a trapezoidal sum theorem. Don't forget that the trapezoidal sum theorem is 1/2 times height times base 1 plus base 2, and don't forget to put base 1 and base 2 in parentheses. Afterwards, I'm now going to use a trapezoidal sum theorem to approximate the value. So I'm going to do 1/2 1/8 parentheses 1/2 times 2 parentheses 0 plus 4, and you close the parentheses, 1/2 times 3, and parentheses 4 plus 13, you close the parentheses, plus 1/2 times 2, parentheses 13 plus 21, you close the parentheses, and then you add another 1/2 times 21 plus 23, and you put that into parentheses. And afterwards, for that, you get 1/8, and when you add all those up, you get 1/8. When you add all those up, you get 10.688 entries. Don't forget to write 10.68800 entries. Don't forget to write entries because that's your units, and it asks for units in the question. So, excuse me while I box my answer. So, now in the problem, it also asks me to explain what this equation is. So, this equation basically is the average number. Sorry, I'm writing right now. The average number of people. The average number of hundreds of people who enter the box between 0 and 8. So that's what this equation means. And when it asks you to explain it, what it means, explain it because it'll give you a point. So it's the average number of 100 entries in the box between times noon and 8 p.m. So for letter C, the question reads, at 8 p.m., volunteers began to process the entries. They process the entries at a rate modeled by the function p, where p of t is equal to t to the third minus 30t squared, plus 298t minus 976 hundredths of entries per hour, for 8 is less than or equal to t, less than or equal to 12. According to the model, how many entries had not yet been processed by midnight? T equals 12. So for this question, you have to take the integral first. Don't forget to take the integral for this question. So you do the integral from 8 to 12, and then you do P of t. So you know that there were 23 entries at 8 p.m. So at 8 p.m. there were 23 entries, as you can see in the table. Let me just finish writing that down. So you do how many entries there were and how many had been processed, and you subtract them from each other, which will give you how many had not been processed yet. So basically you have to do 23 minus 16, and that gets you 7. And remember that your answer is always in hundreds, so you put 700 entries. Oh, I made a mistake. It's already 700, so you just put 700 entries. So 700 entries is the answer. Don't forget to box your answer. And that's how many entries were not processed at midnight. So for D, it reads, according to the model from part C, at what time were the entries being processed most quickly? Justify your answer. So for part C, you just write down the integral that you wrote down for part C, and you write down again that 23 minus 16 is equal to 700 entries, because that's important for D. So for D, first you take the derivative of the rate and equal it to 0. Don't forget that. Always take the derivative of the rate. And when you take the derivative of the rate, that gets you P of t is equal to 3t minus 6t plus 298 equals 0. Because you have to put the rate equal to 0. Don't forget. So from here, just use the 0 feature of your calculator. If you have an 83 calculator, then you can go to Math Calc. But if not, then you could just go to the slope. Use calculator for this. Plug it into your calculator, okay? I'm sorry, if you have an 84 calculator, plug in the 0 feature. If not, just use the slope. It'll give you the same exact answer. So now, once you plug it into your calculator, you get your critical points, and that is 9.814 and 10.816. Those are your critical points. So now you want to find the endpoints to see at what time the entries were being processed most quickly. So you do P of 8, and that equals to 0, right? And then again, you do P of 12, and that gets you 8. And then you do P of 9.814, and that equals to 5.0. That equals you to 5.089. And then you do P of 10.816, which gets you 2.91. So you're looking for the maximum. So you look, and P of t is 8, P of 12 is 8, so that's the maximum. That's what you were looking for, and that's what's being processed. So for question A, it reads, how many people arrive at the ride between t equals 0 and t equals 3? Show the computations that led to your answer. So for this question, you have to use the area of a trapezoid, which is 1/2 base 1 plus base 2. Don't forget to put in the parentheses, and you close the parentheses h. So 1/2 base 1 plus base 2 h. So basically, you take the integral from 3 to 0, because it's asking from time t to 0. T equals 0 to t equals 3. So you take the rate of that, the integral of that, and it's r of t dt is equal to 1/2 times 2 times 1,200 plus 1,000 plus 1/2, in parentheses 800 plus 1,200 equals 3,200 people who have arrived. And don't forget, you do this because at the graph you see that at times 3, 1,200 people arrive. So you just use the graph. Don't forget to use the graph. That will be very helpful for you. Also, R of t is equal to the rate at which people arrive. R of t is equal to the rate at which people arrive. So for B, the question reads, is the number of people waiting in line to get on the ride increasing or decreasing between t equals 2 and t equals 3? Justify your answer. 800 is the people exiting line per hour. That's why it's so important to draw that straight line at 800. So R of t minus 800 is the rate of change for the line. So R of t minus 800 is the rate of change of the line. That's very important. Do not forget that. Excuse me while I switch my markers. So R of t and 800, right? So 800 on 2 is less than t and is greater than 3. So the number of people is increasing between t equals 2 and t equals 3. It is increasing because 2 is less than t, but t is less than 3. Don't forget that. And always use your graph as well. So for 2010 part C, it reads, at what time T is the line for the ride the longest? How many people are in line at that time? Justify your answer. So let L of T be the total of people in line at time T. Okay, so you see I'm writing L of T is equal to 700 plus the integral from 0 to t, R of x minus 800, parentheses dx. So you see I'm writing that because that's the equation that we're going to use for the rest of this problem. And as you can see right now, I'm writing down the second fundamental theorem. And this is really important in calculus and for this problem because it holds for a continuous function on an interval at any point. So right now you see I'm writing L prime of t is equal to R of t minus 800. And that's important because I'm using the second fundamental theorem from the first equation into that. So now you see that I'm doing L prime of t is greater than 0 from 800, is greater than 800 from t is equal to 0 to t is equal to 3. And then you see I'm also doing L prime of t is less than 800 from t is equal to 3 to t is equal to 8. So, and basically I'm doing this because it's I'm doing this because I'm using my graph and I'm looking at the critical points, and that's where I'm getting. The graph is going to be very helpful for you in this problem, so please use it to the best of your abilities. And make sure you're drawing the graph as well. So right now you see that I'm going to start something. So this means that the change from positive to negative means that it's a critical point on the graph. So when it changes from positive to negative, don't forget that it means that it's a critical point on the graph. So right now you see that I'm doing L. So now you see that I'm saying that L has an absolute maximum at t equals 3 because you see at 800. At R of t equals 800 is the only time that there's a maximum. So the maximum is at t equals 3. So the number of people in line at L of 3 is equal to 700 plus the integral from 0 to 3 r of x minus 800 parentheses dx is equal to 700 plus 3,200 minus 2,400, because I'm using the numbers from the graph, so please don't forget to always refer to your graph. And the question asks how many people are in line at that time, and it's 1,500 people are in line when the ride is the longest. So for question D, the problem writes, write but do not solve an equation involving an integral expression for r whose solution gives the earliest time t at which there is no longer a line for the ride. So for D, you have to write the equation L of t is equal to 700 plus the integral of 0 to t r of x minus 800 parentheses d of x. So you see in the problem, it says you want the integral to equal 0. And you do not have to solve it. It says write but do not solve. So you do 700 plus the integral of 0 to t r of x minus 800 d of x is equal to 0. And that's basically the answer. This problem is very simple. It just wants you to write the equation but not solve it. This problem is actually very simple.
Part A of question 4 asks you to find the area of R. To do so, you must take the integral from 0 to 9, 6 ds, and subtract that from the integral from 0 to 9, 2 radical x dx. 6 is the top function, and 2 radical x is the bottom function. When you subtract both functions, you get integral 0 to 9, 6 minus 2 radical x dx. Once you do that, you get 6x minus 2x raised to the 2/3 power over 3 with the bounds 0 to 9. When you plug those into the equation, you get 18. Be sure not to overlook the boundary line y equals 6, because you would do the integral from 0 to 9, 2 radical x dx, which represents the region under, not between the 2 points. Part B asks you to find an integral expression. You get the line y equals 7. With that, you do pi integral from 0 to 9, parentheses, 7, which is the axis of symmetry, minus 2 radical x squared. Two radical x is the bottom function, and you subtract that from 7 minus 6 squared dx. Part C asks to find the rectangle perpendicular to the x-axis. Since the line is perpendicular to the x-axis, all points must be solved in terms of x instead of y. When you do that, you get the integral from 0 to 6 y squared over y, which is the base, and you find the base by doing right minus left times 3 times y squared over 4 dy. You multiply it by 3 because the height is 3 times the base. For part 8 of question 5, you're given the function g of 0 equals 5. They ask you to find g of 3 and g of negative 2. To find g of 3, you must use the fundamental theorem of calculus and do g of 0 plus the integral from 0 to 3 g prime of x dx, which equals 5 plus pi, which is the area of the circles since it's 1/4 of the circle, plus 3/2, which is the area of 1/2 of the triangle. To find g of negative 2, you must also use the fundamental theorem of calculus, and you get g of 0 minus the integral from negative 2 to 0 g prime of x dx, which equals 5 minus pi. For part B, for question 5, it asks us for point of inflection. Point of inflection of g of x shows up on the graph of g prime of x as relative extrema. When we look on the graph, we notice that g of x has point of inflection at x equals 0, x equals 2, and x equals 3. Remember, g of x doesn't need to be differentiable. It just needs to have a relative extrema. For part C, we're given the function h of x equals g of x minus 1/2 x squared. For the first step, you have to take the derivative of h of x, which is h prime of x, which equals g prime of x minus x. And we're looking for the critical point of x, so we know where. So we know that's when h prime is either 0 or undefined. But h prime is defined everywhere, so we're just looking for 0. To do this, we're going to add the line y equals x to our graph. And there are 2 points where the line intersects on the graph. To find the intersection point, we must use x squared plus y squared equals 4. And then using that, we find what x equals, and x equals radical 2. So we know that the critical points are at radical 2 and x equals 3. H prime of x has a relative max at x equals radical 2 because h prime is positive every time g prime is bigger than x. With that being said, at x equals radical 2, when the line intersects with the circle, g prime of x is greater than x. As the function is above the line, it is positive, and when the function goes below the line, it becomes negative. Since it's going from positive to negative, there's a relative maximum. At x equals 3, nothing happens, therefore making it neither a maximum nor minimum, because there is no sign change. We start off below as g prime is less than x, so h prime is negative. Then at 3, it's at 0, and after 3 it becomes negative again, so there's no sign change.
Question 6 asks us to find the equation. Write an equation for the line tangent to the graph of y equals f of x at x equals 1. Now, in order to do this, you need to know the point slope formula, which is y minus y1 equals mx minus x1. Now, they already give us two corner points that we were able to use in our problem, which is f of 1 equals 2, which is basically x comma y, which is 1 comma 2. So now that we have that, we can plug it into the equation. But now we have to find, we have y1 and x1, but we have to find m, which is the slope. Now, as we know in calculus, slope is another form of saying derivative. So we have to take the derivative of, take the derivative of x y to the third. So basically, you just plug in the corner points into that just so you can find the slope. So once you plug in 1 and 2, you'll get an answer of 8. So now that is your slope, which is your m for the point slope formula. I'm just switching my marker colors. So now you finally have our full equation, which is y minus 2 equals 8 parentheses x minus 1, which is your final answer. For part B, it is asking for us to approximate f of 1.1. Now, in order to do this, you have to use the point slope formula from A, the equation we already found. So you plug in 1.1 for x into y minus 2. So the new equation would be y minus 2 equals 8, parentheses 1.1 minus 1. You do the math and you get an answer of 2.8. Now, in order to see if the question also asks to see if the approximation for f of 1.1 is greater than or less than f of 1.1. So basically, in order to find if it is greater than or less than, we have to look for concavity, which is also known as the second derivative. So yeah, I'm just writing some notes down. So as I said before, we will take the second derivative of y, which is the derivative. We take the second derivative of y3, y to the third power, parentheses 1 plus 3x squared y squared. So you're just taking the derivative twice of that equation, and you have to use the corner point 1 comma 2 as they had gave to us previously in the problem alone. So once again, as we did in part A, you plug in 1 comma 2 into the second derivative equation, which is y to the third 1 plus 3x squared y squared. So once you do that, you do some algebra in your calculator and you get an answer of 224. Now, because it relates to concavity and the answer is positive, that means that f of 1.1 is an under approximation. Now, let's say we got an answer of negative 224. Then we would say it is an over approximation because it is negative. Part C asks us to find the initial condition. Now, in order to do this, you need to know the concept of separation of variables. So basically, to do this, you are cross multiplying the dy dx and xy to the third power. So when you do that, it cancels out and you get y to the third dy equals x to the dx. So basically with this, you're just trying to get the x's on one side and the y's on the other. So now you have to integrate both sides. So now that they're integrated, you do the basic rules of integration, which is to add 1, and divide by that new number. Sorry, it's -3 actually. I know I wrote 3 in the problem, but it's -3. So anyways, yeah, you do that. And then you get y over 1 squared equals to -x squared plus c over 1. So you still need y to be by itself. So as I move on to the other side of the board, and basically you're just cross, while I'm rewriting it, after I rewrite it, I'm just going to cross multiply so that y is by itself. So now you have to divide by -x squared plus c on both sides to get y by itself. And after that, you get an answer of 1 over -x squared plus c equals y squared. I'm just taking some time here and thinking. So this is where I'm now plugging in the point that they gave us in part C, which was f of 1 equals 2, which is basically 1, 2. I'm plugging it in order to find C, which is something that we're looking for in order to get the final equation. So once you do that, that is your C, which is -5 over 8. And your final answer will be f of x equals 2 divided by the radical 5 minus 4x squared.